So we've talked a lot already in this week about our essential plant nutrients. So we're in this unit now, we're in nutrient management, and we just finished up on tillage. And we've talked a lot about the 17 essential plant nutrients and some deficiencies that they can cause in plants and what that looks like. We've also talked about the nitrogen and phosphorus cycles and how those cycle through our earth, what that looks like. And we're going to take those into account, especially when we start talking about fertilizers. So that's where we're going to start today. I'm not going to do presentation mode because it does really weird things on my screen when it does that in screen share. So we're just going to go through it this way. If you just want to look at the PowerPoint yourself, that's fine. But if you need clarification on certain parts, that's why I'm providing the lecture, because it will help you through that. So that's what we're chatting about today, is we're talking about fertilizers. So first, what's the purpose of talking about this? So in agriculture, we use fertilizer pretty universally. And when we till, or if we harvest, or maybe we have a certain soil type, there are certain nutrients that can get lost. And we want to replenish those nutrients and provide the adequate amount of nutrients for our plants by using fertilizer. Now, if we use too much, that can cause some dangerous pollution, but we're lucky that we have technology that's increased the efficiency of our fertilizer. So here's our goal when we use fertilizer, what we call soil fertility, meaning that we want something that's going to produce crops well. Our goals as a producer are to increase our yield, or the amount of crops that we have, to reduce our costs in production, and to improve the product of the quality that we're producing. So we want a really healthy, fresh product. We want to avoid pollution, and we actually want to improve the environmental health of the environment that's around our crop. Okay, so that's really our goals of fertility. So there's a couple of common pollutants that we typically see. This is what we call nitrates and phosphates. And you can remember that a nitrate and a phosphate is a polyatomic ion. So a nitrate is like NO3 minus, that's nitrate, and phosphate is PO3 minus, if I can remember off the top of my head. But it's basically a combination of nitrogen and oxygen, or phosphorus and oxygen. And if you can remember, these are anions. So they have a negative charge. Common nitrate can be a common pollution by percolating through groundwater. So if I apply a fertilizer that has a nitrate in it, it can go through the soil from watering, and it can actually pollute the groundwater that's being used in showers, sinks, drinking water, that kind of thing. So it's not safe to drink if you have a lot of nitrates, and it actually causes something called blue baby syndrome, and that's going to inhibit the oxygenation of blood. Oxygen is what makes blood red, and it actually turns blood blue. So if you don't have a lot of oxygen in your blood, you're not getting oxygen to your vital organs. This is actually being found, and you can look up some more research, in fields that are really heavily fertilized or fertilized improperly. It's really common in feedlots and dairies, because feedlots and dairies, lots of cows, lots of fecal matter, and fecal matter is really high in nitrates. That's one of the reasons why we want to make sure we manage feedlots and dairies properly, because we don't want that fecal matter to get into groundwater, obviously because it can make us sick because of E. coli, but also because it's really heavy in nitrates. Phosphates, those can pollute surface waters, again, by runoff. So maybe if we have a river, stream, lake, those can actually promote algae growth in rivers and ponds, and it tends to deplete the amount of available oxygen in water for fish. So fish tend to get killed off a little bit quickly, and we have less fish. We have less birds, amphibious animals, insects, those types of things. So we want to make sure that we don't have any phosphates in those waters, and that's going to make sure we want to make sure that we maintain the environment that we have. So we want to use fertilizers wisely and actually improve the environment. So we can actually, through the use of fertilizers with crops and trees, we can remove more CO2 from the air. We can decrease sediment and dust that's around there locally, and we can actually decrease erosion. And it's going to play a really important role for the future of our planet. We want to make sure that we have fertile crops, that our plants are pulling even more CO2 from the air, because they're going to release more oxygen into the air and help improve our planet. So those are some goals that we have when it comes to using fertilizers. Now, when we look at fertilizers and we talk about commercial fertilizers, meaning fertilizer that you can buy at any store, maybe Higbee's, Tractor Supply, Home Depot, Lowe's, those commercial fertilizers are going to have 3 numbers on the front label that are separated by dashes. So it would look something like this. This is the analysis or percentage by weight of the 3 major nutrients plants need. And percentage by weight is going to be really important here. So those 3 nutrients stand for nitrogen, phosphorus, and potassium. Okay, so that's what those 3 numbers stand for, N, P, K. That's going to be really important here. So fertilizers that contain all 3 of those things are going to be considered a complete fertilizers. You may see something like this. It's called a 0-20-20, which means that there's no nitrogen present. That's going to be an incomplete fertilizer because it's going to lack one of those major nutrients. So I might use an incomplete fertilizer if I have soil that's really high in nitrogen. If you think back to when we used our soil tests, right? That's why we talk about those tests first, is because those are going to come into play when we start talking about what we need for a fertilizer. So some other information we might see, it's actually required by law. You'll see the net weight or the weight of the fertilizer, the brand and grade, the guaranteed analysis or NPK, and always we can find the manufacturer. So let's take a look at how we actually read a fertilizer label. The 3 numbers that are here, and this is a really great image to help us see. Nitrogen, there's 24% nitrogen, there's 5% phosphorus, and there's 11% potassium. So this is really just the percentage. Now you'll notice all of these numbers combined, it's not 100%. So fertilizers will contain other nutrients and filler like micronutrients, those types of things, just like you read in the article before. Those things can also be found in fertilizer as well. So that's what these numbers, although it doesn't equal 100%, the other remaining 60%, 40% NPK, 60% other nutrients and fillers. So let's take another look at another example, okay? Here we have a lawn fertilizer. We know that, again, by the numbers on the front, it's 24% nitrogen, 6% phosphorus, and 12% potassium. So let's talk about, we talk about percentage by weight. Here's what that looks like, and here's how we break it down. Let's say we have a 10-pound bag of fertilizer labeled 5, 10, 5. We want to know how much by weight each of these numbers contains. So we already know that right here, these are the percentages of each. And the 80% can be comprised of other nutrients and fillers. And all we really need to do is, and I know it looks like you want to move the decimal back twice. You're not doing that here. Basically, if you look at it here, we're going to figure out by weight. That's actually 0.5 pounds, a half a pound of nitrogen, 1 pound of phosphorus, and 0.5 pounds, half a pound of potassium. And that's actually, there's 8 pounds there that can be comprised of other nutrients and fillers. Okay, so what we really can do here, if you think about the whole 10%, what's 5% of 10 pounds? Well, that's actually, 5% is half a pound, right? If you think about what's 10% of 10, that's 1 pound. What's 5% of 10 pounds? Half a pound. So how we figure that out is we're going to turn this into a decimal. You move that decimal back twice, so you get 0.05. You multiply that by 10, and that's going to get you that half pound there. So you're going to take this percentage, multiply it by the pounds, and that's how you're going to get that poundage there, or the percentage by weight. So let's practice a bit more. So the first number is going to give us the concentration of nitrogen. Nitrogen, as you saw in your essential nutrients activity, nitrogen encourages foliage growth and provides a lot of other benefits. So a 5-10-5 fertilizer will contain 5% nitrogen by weight, and for every pound of fertilizer, there's only half a pound of nitrogen. So again, the 10-pound bag meant it would only contain 0.5. So the middle number refers to the concentration of phosphorus. Phosphorus contributes to many fundamental plant processes, such as growing roots and setting flower buds. Flower buds are essential for pollination. Pollination is essential if we want fruit growth, such as tomatoes or almonds. And a 5-10-5 fertilizer would contain 10% phosphorus by weight, but only 0.1 pounds of phosphorus. So a 10-pound bag mentioned above would contain 1 pound bag of phosphorus. And finally, that third number, potassium, it's our concentration of potassium. That's going to contribute to health and vigor, such as making plants bigger, such as producing more leafy growth. That would contain 5% or 0.05 pounds, and a 5-pound or 10-pound bag would contain a 0.5 to contain half a pound of potassium. Okay, so if we want to figure out how much fertilizer we apply, here's what we look at here. So you're going to look at, it could be a percent of nitrogen, potassium, or phosphorus or potassium, it depends. But what you're going to do is you're going to look at the bag and you're going to look at the recommended nitrogen rate. You're going to look at the percentage of nitrogen and fertilizer, the area that you're going to provide that place over 1,000. So if you're going to actually do this, let's say you're going to do this on your front yard, what that might look like. So let's try it. So we have a grass lawn that needs to be fertilized, and Jake has found a bag of 1688 in our garage. If we need to put 1 pound of nitrogen per 1,000 square feet of our 3,000 square foot lawn, how much fertilizer do we need to apply? So here's what we would do. So the recommended rate is 1 pound. We're going to put that over our percentage of nitrogen and fertilizer. We're going to multiply that by our area, or square feet, which is 3,000 over 1,000. We're going to get 6.25 times 3, which means in that particular area, you're going to apply 18.75 pounds of fertilizer. Okay, so if you were to do this in real life, let's say you're working on your SAE project and you're noticing that your lawn is yellowing. If it's yellow, it actually means that it would need some nitrogen or a fertilizer that's heavy in nitrogen. So that's why you would want a fertilizer like this, which is probably why it was bought in the first place. If it's brown and dead, you probably need to water it. I would think about that. But again, you have to think about like what your deficiency is showing, or maybe do some soil tests to figure out what you need. But that's how we're going to figure out how much we're actually going to apply. And this is what farmers do on a daily basis. But they're doing this in a instead of a 3,000 square foot lawn, they're going to do this on a 10,000 square foot plot of land. So that's something that we have to think about. If you have any questions, let me know. But we'll have some time to practice with this as well.